variable acceleration in one dimension. So kinematics, 1D motion, variable acceleration, so we have to use calculus, and this is what we're looking at. So if you're given a function for displacement, you differentiate ds by dt, you get velocity. If given velocity, differentiate dv by dt, you get acceleration. And going in the opposite direction, so from acceleration to velocity, velocity to displacement, we are integrating with respect to time. You can work out the value of acceleration for a given time and then use F equals ma to maybe calculate a force. So on a velocity time graph, if you have a constant gradient, it means you have a constant acceleration, so you can use suvat. Where the gradient is a variable, that means acceleration is a variable, so we use calculus. To work out the area, we use integration. The area B through integration will turn out to be negative. Change the sign, make it positive. If you add both of these areas together, you get distance. If you do the area of A minus the area of B, you've calculated displacement, where the area under a velocity time graph typically represents displacement. Example 1. A particle with a mass of 6 kilograms is moving in one dimension, it's moving along the x-axis, and its displacement is a function of time. We want to work out the resultant force on the particle at the instant when t equals 2 seconds. F equals ma, where F is the resultant force on the particle. The mass is 6 kilograms. To get the acceleration, we need to work out d2s by dt squared. We have to differentiate this twice. Remember, we're given the displacement function. You differentiate once to get velocity, you differentiate again to get acceleration. So the first derivative, if we differentiate this term, we get this term, and if we differentiate the second term here, we get this term here. And now the second derivative, d2s by dt squared, so differentiating this once more. So now we can see that acceleration is a function of time. It's not a constant. So the suvat formulae cannot be used. T is equal to 2. We substitute 2 into here, and we get our acceleration. This acceleration is for this particular value of time. So F equals ma from before, so substituting in A into here, we have 6.51 newtons for the resultant force. Example 2, this time we're given acceleration as a function of time. To work out the velocity, we have to integrate. So we're starting here, we're trying to work out velocity, so following this path, we have to do integration with respect to time. So integrating cosine, where the angle here is in radians. So using this diagram, we're starting with a positive cosine function. There's a plus sign here. When we integrate, we go anti-clockwise, so that will take us to a positive sine function. And then we have to divide by the coefficient of t, like so. Add on the constant of integration. We're given some conditions. When t equals 0, so initially the velocity was 0.3 meters per second, so this is given. We can substitute these values in to work out the value of c, our constant of integration. And if we substitute in t equals 0 into here, we get sine of 2 pi times 0. The sine of 0 is 0. So v equals 0.3 goes here. This term is 0, that means our constant is equal to 0.3, so we get this. For practice, try these questions.